بسم الله الرحمن الرحيم رب زدني علما.
Now again, the last part about the RIP is the advantages and disadvantages. Okay, when you talk about advantages are very less. The main thing is it's very easy to configure. The one of the best easy to configure, because if you when we learn OSPF, you will understand why it is easy. Because in the OSPF there are many designing rules, like we have to follow the OSPF area designs and the way the process goes. It's a little bit complex, but of course scalable in a bigger scenario. So OSPF is designed like that. And also OSPF uses more CPU resources compared to the RIP. So if you compare, these are the very few basic advantages we can say, but there are more drawbacks or the limitations with the RIP which makes not widely used. Like one of the main thing is bandwidth utilization, because for every 30 seconds it is going to send a periodic update, which is going to consume a huge amount of bandwidth only for updates. So that is really not good. When you compare with EHRP or OSPF, OSPF only send hellos. It will not send for every 10 seconds. That too, it will only send the hello. It will not send the updates. And the updates are incremental. If you take OSPF or EHRP, incremental updates. But here there is a periodic updates. That is again, which makes more bandwidth consumption and the CPU resources on the device. And another factor we don't really prefer to run RIP is it only works with hop counts, which means, let's say from the router A to reach 50 dot network, we can go from this side, there are 2 hops. And if you go from this side, there are 3 hops. Okay. So 2 hops and 3 hops. Okay. So which is the best route? The best route is always decided based on the shortest hops, which is 2 hops. But there is a possibility that this route is having a bandwidth of 150 Mbps and this route is having just 5 Mbps. So in most of the time, especially in routing, the majority of the factors or the major factor to decide the best route has to be the bandwidth, not the distance. Okay. Of course, here it's not the distance, it's not the number of routers. So the RIP will not see the bandwidth. It will only see the number of routers in the transit, which is not actually a good idea to calculate the best route. Because when they introduced, they just wanted to make it simple. That time the bandwidth was not really a big factor, considering very less bandwidth. But in today's scenarios, the bandwidth plays an important role. So if you compare this, even if you take this 50 Mbps, so it's like 3 times better than the other one. So the current protocols we use, like EHRP or the OSPF, which are the alternate protocols, basically they simply use the bandwidth as a major factor in deciding the best route. The other reason we don't use RIP is applicable for small organizations. And especially in today's scenarios, you have hundreds of routers connected, and connecting only 15 hops is really not a scalable solution. Okay. So that's not a scalable solution. So that is another reason we don't prefer to run RIP. And also the convergence process is also very slow. So if you compare the OSPF takes only 40 seconds, EHRP takes only 15 seconds. If the best route goes down, alternate use. But whereas here it's almost like 4 to 7 minutes, which is again a huge amount of convergence time, which it takes to calculate the alternate route, which is again another reason we don't use RIP. So in today's scenarios, today's syllabus, you don't find the RIP, but generally we just go through with the RIP to understand the foundations of the dynamic routing, which makes very much easy for us to understand the core dynamic routing concepts. But once we jump into the OSPF or any other protocol like EHRP or any other protocol, you will see how it works at the back end. Okay? So as we move on into the next sections, we will try to use some other protocols. Like OSPF is the best alternative protocol or the majorly used protocol you will see in most of the production networks.